Okay, so we've been learning how to solve logs. What we're going to do now is apply those to word problems. And so the way these usually work is you're given an equation. For example, here's a couple. These are equations that you may or may not have seen. In fact, a lot of the ones that might be on a test or an exam you won't have seen. But solving for an equation you do know how to do. And now with logs, you also know how to solve for equations where the unknown is in the exponent. So that's the kind of question we're going to be looking at in the next lesson here. Okay, so the first one, probably one of the most common, is a compound interest formula. These formulas are actually the same, they just have a little bit different letters. If you were given one of these formulas, you would usually be told what each of the letters stands for. So it would, if you could read that, you would figure out where to put things. So let's try this first question here. And I see there is a compounded in here, and I see investment, and so that I know this is the formula that was on the previous page. If you're not sure what formula, most of the time they'll actually give you the formula in the question. Okay, so you don't have to worry too much about, well, which formula should I be using? Usually they give it to you in the question. In our homework, not so much, but on a test or exam, they would be. Okay, so what are we looking for here? It says the principal, that's P, 1500, that's invested, and it says the rate is 4%. So I'm going to put 0.04, right? Because 4% means 4 out of 100. That's how I get 0.04. And then it says compounded quarterly. That means there are 4 compound periods. So that's what N is. Okay. And N again is 4, and it says 7 years, so I'm going to multiply by 7. So this is a question you could have done last year. You just have to type exactly what you see into the calculator. Be careful when you do that you put brackets here too, because you want that multiplied first. Okay, and if we just punch that on the calculator, you end up with $1,981.94. Pretty straightforward question. Okay, that's not a question that I would think that you're going to get. More likely you're going to get one like this one. Okay, you'll see in this one that the unknown is in the exponent. So again, compounded, invested, I know this is this formula. So I'll write that down, and then let's fill in what we know. It says the principal is 2,500. And notice I had to change that, the numbers were backwards. And the final amount is 2,800. So the amount of money grew. We just have to figure out how it grew. Invested at 0.0225, and it says compounded monthly, so I'm going to put 12 there. And then I have 12 here, and the question says, what year? In other words, what is the time that this was that this happened? How long did it take for the money to grow from 2,500 to 2,800? Okay, so I gotta kind of peel this apart, and I have to solve for t. So the first thing I'm going to do is I'm going to divide everything by 2,500. So if I do that, I end up with, I'm not even going to put it in the calculator yet. I'm just going to leave it like that. And I'm going to not touch this either, because I don't want to do any rounding off yet. Okay. Okay, now what I'm going to do is I'm going to divide. Actually, before I divide, I'm going to take the log of both sides. So I'm going to have log 2,800. Now you could divide this. You could go 2,800 divided by 2,500. In fact, maybe I'll just divide by those two zeros by 100. So I'll just put that. And I'm going to take log here. And if I put this in the calculator, I get 1.001875 12t. Now, why did I take the log of both sides? Well, taking the log of both sides allows me to move this to the front. Takes it out of the exponent. So then I'm going to be left with log 28 over 25 equals 12t log of 1.001875. And now it's pretty simple. I want to solve for t, so I'm going to divide this whole thing by 12 log 1.001875. Do the same thing on the other side. You definitely need practice with this because you have to make sure you know how to put this in the calculator. Okay, so the 12s will cancel out here, this will cancel out here, and I'm left with t on this side. And on this side, I believe it comes out to 5.04. And if you read the question, it said to the nearest quarter of the year. So the nearest this would be is 5 years. Okay, so that's the first example of an application of log question. Okay, and here's another one. This is another. How do I know this is going to be a log question? Well, I see that my unknown is in the exponent here. So pretty straightforward. I'm going to probably use logs to solve this one. But you won't have seen this formula before. It's a brand new formula. Okay, so we just need to be able to decipher it. It says if the cabin pressure in an airplane is less than 70, passengers can suffer altitude sickness. To the nearest kilometer, at what altitude is the atmospheric pressure 70 kPa? I believe that's kilopascals. So where does 70 go? Well, that goes in for P. All right. And you can see now that my unknown is H, and it said to the nearest kilometer. In other words, how high is the plane? How are you going to do this question? Well, same thing. We want to peel everything away so that H is by itself. So we're going to start by dividing by 101.3. Be careful here. You can't do this multiplication, right? Because H is attached to this number. So we can't do that multiplication. We have to leave that attached there. Okay? And I'm not going to actually do that. I'm just going to take log of both sides now. I can see that's going to be a decimal. I don't want to round off yet, so I'm just going to leave it like that. And then if I take the log of the other side, I'm going to put H in front right away. All right, so that's what I get. And I can now divide by log of decimal 88 to isolate H. And when I do that, I get 2.89. And what's 2.89? Is 2.89 kilometers. Okay? By the way, could you graph this function? Could you go and graph this up here? Well, you should recognize that it's a decreasing exponential function. It's decreasing because the a value is less than 1. So a real quick sketch here, I know that it's going to be this kind of a function. Okay? What is the y-intercept? Well, if h is 0, this would be 101.3. Because decimal 88 to the power of 0 would be 1. Okay, so you kind of get the idea of what this function might look like. What did we just solve here? We just found that the height is 2.89 kilometers when the pressure is 70. All right. So, few more word problems. These look a lot more complicated. Okay, and this is typically the kind of question that's going to show up in your exam. And it'll show up exactly like this one. It'll give you a formula. Okay, here's your formula. And then it lists all of the information. In other words, what all the letters stand for. Okay, and I have never seen a question that is asked that isn't in our homework. So I will give you some homework with different formulas like this. Get used to at least trying all of them so that you kind of recognize what the formula looks like. And the reason you want to recognize them is this is actually a little trick here. It says I is the interest rate per compounding period. This is the divided that we had in the previous compounding question. What you actually have to do here is go interest divided by the compound periods. Okay? And that was n in the last formula. That's not shown in the formula itself here. Okay? So let me show you what I mean. I'm going to write out the formula. And we'll put in our missing pieces. Okay, what does it say? It says how many monthly investments. So in this type of formula, FV is the final value. R is how much you're putting in every month, every time you invest. So R is 200. Would have to be made into an account that pays 6% annual interest compounded monthly. Okay. Where does that go? Well, we have 1 plus. Now, remember I told you I was the interest divided by the compound periods. That's a bit of a trick because it doesn't tell you to do that. Okay, and N goes there. Sorry, we don't know the number of investments. We don't know how many times. It says how many monthly investments. So we don't know N. Okay, and down here again, we'll put 0.06 over 12. And they tell us that the future value or the final value is $100,000. Now, I don't know about you, but this is a pretty interesting question. I want to know how many times do I have to put $200 in the bank so that I can have $100,000. Not bad. Okay, what now? Well, I want to try to again peel everything away to get N by itself. So why don't we put this in the calculator right here, and whatever that is, we'll divide both sides by that amount. Okay, so just putting it in my calculator here. You guys can try the same thing. All right, so I put that in the calculator and I get 40,000. And then I'm going to leave 1 plus 0.06 over 12, like that. So I'm going to divide both sides by 40,000 and I end up with 2.5. Okay, now what? Well, I'm going to add 1 to both sides. Okay, and now I want to get that exponent out of there, so I'm going to take the log of both sides. That will allow me to write N in the front. Okay. Like so. All right. Now what? Well, I need to divide by all of this stuff. Okay, and I think that works out to 1.005, so I'll just write that short now. So that cancels out. Leaves me with N is 251 payments. 251 payments, 12 payments in a year. You're looking at about, what, 20 years? You have $100,000. Okay? All right. This formula is very similar. This time, though, you're paying off something. So you're paying interest. You're not collecting interest. Subtle difference. When you have the money, the extra interest you will be getting. But when you're borrowing something, in other words, making payments, you're actually paying interest. You have to pay extra. So that's a subtle difference in this formula. Okay, I'm going to take a little break. Why don't you guys see if you can set this one up? See if you can place all of the values in there and solve it as far as you can. Okay? All right, hopefully you've had a chance to give this question a shot. So there's your formula, and I want to put all this stuff in. So that someone buys a car for $15,000. That's the present value of the car. And they make payments of $300 a month. Okay. Again, what do I have to do with the interest rate? I have to consider that it's compounded monthly. Okay. And now a little bit different, the n is negative in this formula. All right, so it looks pretty similar. We're going to go about solving this one almost the same way. Okay, first thing I want to do is I'm going to again deal with this right here. Okay, I'm going to divide by 0.06 over 12, and then I'm going to divide both sides by what I get there. Okay, and when I do that, I believe I'm going to get 0.25 equals, and then I'm left with 1 minus 1.005 power negative n. Okay, just double check that. Yep. Okay, now what? Well, if I take those big brackets away, I can subtract 1 from both sides. And then I'm going to get negative 0.75 equals negative 1.005 all to the negative n. Okay, I'm going to divide by a negative. I can do that because this negative is outside of the brackets. Okay, so now I have 0.75 equals 1.005 to the negative n. Let's take the log of both sides. Okay, so then I'll have log of 0.75 equals negative n log of 1.005. Divide both sides by log 1.005. And I get negative n is negative 57.68. So I'll divide by negative again. I get n is approximately 58 payments. By the way, it's not part of the question, but if you make $300 payments 58 times, you end up paying $17,400. Just a little note to you, those of you that are thinking of buying a car, right? You didn't pay $15,000 for the car, you paid $17,400 when you make payments. Okay? All right. My least favorite formula. This is a strange formula. Okay? This one, the Richter scale formula here, m is the magnitude. Okay, I is the intensity of I is the intensity of the vibrations in microns measured on a seismograph that is 100 kilometers away from the epicenter of the earthquake. S is the intensity of a standard earthquake, whatever that means. I don't know what a standard earthquake is, but that's how this question works. Okay, so let's check this one out. It says the most intense earthquake ever recorded in Chile in May 1960 was a magnitude of 9.5. So looking at the formula, I'm going to write it down here. M is log I over S. I believe that was it. Yeah. Where does 9.5 go? Well, it goes in for M. Okay, so I have that. And it says calculate the intensity of the earthquake in Chile in terms of a standard earthquake. So somehow I want to get this out of the log. I want to have that with the 9.5. Well, if you remember, when you have a log equation with one log, you can change this to exponential form. Okay, what's the base of this log? It's base 10. So I'm going to put a little 10 there. This is the same as saying 10 to the power of 9.5 equals I over S. And now if I want to find out what the intensity of this earthquake is, I'm going to multiply by S. So I have 10 to the power of 9.5 times S is the intensity of that earthquake. Well, for those of you that aren't sure, that's a pretty big number. 10 to the power of 9.5. That's, well, something like 3 billion. Well, that's a pretty big number. 3 billion times as powerful as a standard earthquake. Okay? And that's it. We don't really have a number. We just have this power of 10 times S. Okay, now there's another earthquake. The Haiti earthquake is a magnitude of 7, so let's do the same thing with that one. M is log I over S, and we're going to put 7 there. And again, let's change it to exponential form. So you have 10 to the power of 7 is I over S, and 10 to the power 7 times S is the intensity of this earthquake. And the question says, how many times as intense is the big earthquake compared to this one? So let's compare 10 to the 9.5 S over 10 to the 7 S. We're comparing the two earthquakes. Okay, this one is the Chile one. This one is the Haiti one. And you can see we can do some canceling here. Using our exponent laws, you get 10 to the 2.5 times as powerful. All right, we're going to stop there. I'm going to give you some questions to do. Do your best to do some of these. Some of them are going to be tricky. Some of them will be exactly like ones we've done. I'll tell you right now on your test, I'm going to give you a couple of these questions. I'm going to give you a choice. You pick which one you want to do, but there's also going to be a few multiple choice questions. You will have to know how to use these formulas. All of the ones we just covered there, so make sure you do a good job going over that. Okay,